So the last unit of the year has nothing, not a little bit, it has nothing to do with anything we've done so far. It is a completely different branch of mathematics. This is an algebra course. What we're about to learn is statistics. And over the years, as curriculum has changed over the past decade, I think that, because overall, who knows, I don't know what the impetus of it is. Maybe it's because colleges and universities want more kids studying this. But statistics has kind of crept its way into algebra. It's not just this school, it's not just this district, it's across the nation now. First it made its way back into Algebra II, and then now it's even back into Algebra I. Okay? You may have even seen some of this in middle school. I've never taught in middle school, but I'm sure, when I show you the first thing, hey, what's the mean? If I have a group of numbers, what's the mean? What's another word for mean? Yeah, the average. Has anybody here never heard of mean before? You've never heard of mean? Average? Oh, okay. And when you study mean, what other two, it kind of just like jingles, it like rolls off the tongue. What other two types of measurements do we also usually study together with mean? Median and mode. Mean, median, mode. So we'll go over them. Oh, I guess I have mode a little further down the page, but it's there. It's coming up. So, when you statistics is the math that revolves around measurements that concern data. Data is like information. If you're given information and then you want to be able to interpret that data to try to gain something from it, that's what we do when we deal with statistics. In many cases, it's you try to use statistics to be able to get a small sample, learn something about a small sample, and project that over a larger population. It could be maybe because you want to know who's going to, who people are going to be voting for in the next election. It could be used to figure out, what are some trends that are happening in, with student grades and whatnot. But that's what we're going to learn. We're going to learn different measurements. And it seems to be working a lot for somebody who's never heard of. Huh? Yeah, I know, but I could let's just go through it. You just finished saying you've never heard of it before, so these are all going to be different measurements that can be taken when you're given a group of numbers, when you're given a set of numbers. So the first one is the mean, okay? Also known as the average. You should be familiar with average. The way you find average is you add up that set of numbers and then you divide by how many numbers there are. Okay, that's also known as the arithmetic mean. The median, okay? Median and mean are very similar because they tend to tell you something about the center of a group of data, like what's in the middle of a group of data. But they're not the same. Without reading, can somebody tell me what median is? What you know from previous knowledge about median? Nobody remembers anything about median? It's the one number that's in the middle. See, mean asks you to add up all the numbers and divide by how many numbers there are, so that kind of tells you. I'm trying to define it without using the words, but that tells you like what the middle should be, I guess. Whereas median tells you where the middle is. Okay, in order to find median, you have to put numbers in numerical order from least to greatest and pick the one in the middle. The problem is, depends on how many numbers there are in a set of data. Because you're only going to have a number in the middle if you have an odd amount of numbers. If you have an odd amount of numbers, there's one in the middle, and then whatever. If you exclude the one in the middle, you have the same amount of numbers on each side. You have the same amount of numbers that are less than as the same amount of numbers that are greater than. But if you have an even amount of numbers, then this median, it almost acts slightly as an average because you would have to add, because now when you have an even amount, like let's say I have 10 numbers. what would be the two numbers in the middle? 10 is an even number. What would be the two numbers in the middle? If I were to have 10 numbers, if I were to write 10 numbers on the board in order, what numbers would be in the middle? The fifth and sixth, sure. I'm supposed to. Do I have to open it or something? Do I keep it or just go ahead and sign the stuff on the inside? We have 7 class periods in a day. What period is in the middle of the day? What period where like when you're sitting in this period, you've already had as many classes as you still have left in the day? 4. Why? Because there's 7 periods. 7 is an odd number. When you have an odd number, you clearly have a number that's in the middle. When you're sitting in 4th period, you've already gone to 3 classes, assuming you got to school on time, and then you still have 3 classes left to go. That's right in the middle of your day. But if we were to move to 8 periods, now there would be 2 classes that would be in the middle. Okay, it would be your 4th period and your 5th period. The one I asked you 10, if it was 10, it'd be 5 and 6. So if you have an even amount of numbers, you're supposed to add the 2 in the middle and then divide by 2. Now, I don't know, but I haven't looked at every single question that's in this packet closely, but just if it ever comes up, the main difference between mean and median, because if you want to try to get a measurement of what's supposed to be in the middle, is that, I mean, I would probably argue that mean is used more often, average is used more often, but they say that median is a better measurement of center because it's less influenced by the extremes. Let me give you a perfect example, right? Let's say I want to figure out which of my classes has which one of my classes is the best. I only have one of these Algebra 1s, but let's assume I had 6 Algebra 1s. And I want to know which class is performing the best. Okay? And I look at this class average. This semester, you guys are actually doing pretty good. It's like somewhere in the 70s, right? But when I see somewhere in the 70s, I'm talking about mean. I'm talking about average. So the problem with that is that doesn't necessarily give me a good indication of how everybody's doing, because without giving names, there are at least 2 of you in here that are doing way better than everybody else. Those would be the extremes. So what happens is, if even on the contrary, if you had a pretty good class, but you just had 1 or 2 knuckleheads that were doing like nothing, and had like these averages of like 0 and 7 or 8, that had like a really low number, that's going to affect the mean of the entire class more than it would the median. When you have numbers way out in the extremes, it affects the mean more than the median. So if you want to have a better idea of what the middle is, they say that the median is usually a better indicator because it's less susceptible to the extremes. It's not going to be affected as much by the extremes. Does that make sense? Like if I were to tell you right now, this class average is 74, does that mean that everybody has a 74 here? No, probably not. Now, a lot of you probably would be around the 74. That doesn't mean a lot of you are a 74. But then the question is, why do we have that 74? Is it because everybody's close to 74? Or are the majority of you maybe in the 60s, but then we have a couple of people that are doing really, really, really well? Or conversely, maybe a lot of you guys are in the 80s, but then you have a couple of people who never show up to class, they do nothing, their class average is like a 4%, and they're bringing the extremes move averages more than they do medians. So I know that should be coming up later, so when it does come up later, now you know. Okay. Another thing you're going to start, when we start looking at spreads, distributions, I'm not a very good artist, but that's okay. When you start looking at yeah, this will be more next week because next week we start getting more into distribution. You start seeing histograms and different types of charts and stuff. Um, when you start looking for what's in the middle, right, you're gonna start saying, hey, like median, mean, like let's say. These are two different distributions. Sometimes they'll give it to you like this as a line. Sometimes you'll see it as like a bar graph, okay, or whatever. Um, so what'll happen a lot is they'll say, hey, this little line that's drawn. These are two different ones. These have nothing to do with each other. They're two different ones. They'll draw a little line and they'll tell you, hey, that's the median. Okay, today we'll get into a little bit with box and whisker plots. Or if we don't get to it today, it'll be this week. Where we'll say and they call it Q2. Um, they don't do that on these, but they do that on the box and whisker plot. They'll say that's the median, but then they'll ask you, hey, if the median is where I just drew that green dotted line, if this is the median, where would the mean go? The mean is always going to go on the side of the tail. Think of it like a little rat with a tail. If this were like a rat, like where would the tail be, on the left side or the right side? I know you're stuck with my drawing. I don't have the best drawing, but if I were to, does that look more like the tail is on the left or on the right? Oh yeah, on the left. I did a little bit better with this one. This one you can tell. Where's the tail? Where's El Rabito on that one? On the right, yeah. So if you were to be asked where would the mean fall, the mean is always going to fall on whatever side the tail's on. Just keep that in mind also. Yeah. The tail to outline. One doesn't necessarily have anything to do with the other. Okay. Yes, an outlier could fall into a tail, but that doesn't necessarily mean that a measurement that's in a tail would be an outlier. Kind of, it could be. It could be as a histogram. It could be a dot plot. When you start looking at frequency, like how often something is occurring, all right, we're gonna store these measurements are gonna come back. So, so let's see if we can do some hands-on learning. You guys, or if it was I think it was my other classes that had a better one. Okay. I think I have better examples of this, but here's an example. And it's perfect. It doesn't have any names on it. This is a histogram of for my trader courses. I gave them a practice test for the midterm. Before they took their midterm, they took. I know you guys took one also. The difference is yours was created by the department, whereas mine I created it myself, right? So if I were to get this histogram, and I know it's rough, I know it's not perfectly smooth, but if I were to kind of trace more or less, if I were to trace, smart. I need to whatever. I won't be able to draw it, but if you can just kind of trace the tops of where they are, would you say that the tail is more towards the right, towards the higher numbers, or more towards the left of the data? Yeah, it looks closer. I should be able to draw, but I can't draw right now. But if I were able to draw, um, it's that I need to restart my computer. I guess I haven't done it in a while. There's the same thing, right? So if I were to trace like a little line on top, the tail, okay, like the little tail appears to be on this side of it. This is the tail here, right? So what I would assume, if I could look at the data for this, which I actually do have it, I can look at it now. What it looks like is that, remember, the median is going to be wherever the highest frequencies are. So the median probably looks like it's somewhere around here. That has to be. You're not going to be sure by looking at this, but it looks like the median here would be probably somewhere in this like 12 range, some of that 13 range. But the mean should fall on the side of the tail. Whatever side the tail is on, where the mean is. All right. The one thing I can be pretty confident about looking at this data, it looks like the mean is going to be greater than the median. Okay? And let me see, because I think I actually do have that data. Let me see. Before it was normalized. Their mean, it's about the same. It was about the same. Wait, yeah, is this the same one? Oh wait, no, wrong one. Should be this one. Midterm. I was looking at a different test. Yeah, it's still pretty close. The median here is 9. So I was saying the median should be around 10, but it actually ended up being around 9. This was the median, and the mean was around 9.9, so closer to 10. Well, at least we were right about that. The mean was closer to where the tail is. Does that make more sense now? Don't really need to get into that this week. That's more next week. But I just want you to know on the front end, those are the two main things people talk about when they talk about mean and median. Okay, let's keep on going down the page. Quartiles. This we will get into today. Quartiles, the reason why it's blue, what else do you see that's blue here? The median, right? Quartiles has only to do with median. It's basically the median of the median. If I get a set of data and find the median, I'm cutting it in half. We talked about like, hey, what's the median period of the day for you? 4th, right? Well, now if I have period 1, 2, 3, 4, 5, 6, 7, and I tell, okay, the median is 4. Well, what that's doing now is it's breaking the other periods into 2 teams. You have the periods before and the periods after. What would be the median of the periods before? 2. What would be the median of the periods after? 6. Okay, so what you call 2, you can either call it the lower quartile or you call it quartile 1. Whatever the first median of the median would be called quartile 1. Whatever the second median of the median is, that's quartile 3, or you can call it the upper quartile. One thing you need to be aware of, and we're talking about something here that we're all familiar with, right? Periods of the day. We said how many periods of the day are there? There's 7 periods in a day. Is that an odd number or an even number? An odd. When you have an odd number of elements of data, they call those elements, like each little, like whatever numbers that you have. If you have an odd amount, when you're going to calculate quartiles, you have to take the middle one out. In order for there to be 3 and 3, you have to exclude the one in the middle. if we were to be let's say we were to be in an 8-period day. Okay, that's an even number. In order to figure out the quartiles, we would have to leave everything and nothing would be excluded, and then you would have 4 and 4. How would you then find your quartile 1 and quartile 2? The same way you do with median. How many numbers are on the left side? 4, right? If there was an odd number, cool, let's pick the one in the middle. But since there's an even number, you'd have to average the 2 in the middle. What's the average of 2 and 3? Huh? 2.5. Your quartile 1 would be 2.5. This will make more sense when we start doing examples. What would be quartile 3 here, or the upper quartile? 6.5. If it doesn't make sense, it'll make more sense when we start doing examples. Mode is just the most frequent. This is what I'm going to spend the least amount of time on. We don't really use a lot of mode. Just things to know about mode. If no number appears more than once, there is no mode. That's something where, like, if you don't look it up, you wouldn't know just using logic. If every number appears exactly once, that set of data has no mode. Okay? But if there are 4 different numbers that appear 3 different times and 3 is the most, then you are able to have multiple modes. It is possible that you could have more than one mode. And if you're eating ice cream, then you're eating a la mode. So that's also important. Okay, range. Okay, thing to remember about here. This is color coded for you. 2 types of range. The thing we're doing in common is subtracting. When you calculate range, you're subtracting. When you calculate regular range, it's just the biggest minus the smallest in the entire set. When you're being asked for interquartile range, it's always upper quartile minus lower quartile. This is used to figure out spread, to see, like, how spread out scores are. But this is used to calculate something that Nakai said earlier, which are outliers. Let's say I wanted to look at some grades in a group of people to say, hey, maybe these students were misplaced. Maybe these students should be in a higher level of math or a lower level of math. If I wanted to measure, at the very least, do these 1 or 2 students, however many you're looking at, do they belong with the rest of the group? Or are they considered outliers? An outlier is something that it just does not belong with the rest of a group in data. And the way that you calculate outliers is once you get this interquartile range, you multiply it times 1.5. Feel free to paraphrase if you don't understand the way I wrote this. I don't know why this came out this way. I guess maybe you should put, I think I used to have a plus minus there. There should have been a plus or minus. So you get the upper quartile, and you add 1.5 times the interquartile range. You get the lower quartile, and you subtract 1.5 minus the interquartile range. If anything falls outside of that, it's considered an outlier. It'll make sense when you see the examples. Yeah, this next one is kind of an example. It's like a graph. Look, this is the main, as far as data displays, ways to display data, this is the focus of this week. We don't get into histograms and other types until next week. Okay, box and whisker plot has everything to do with median. So here, let's say this is a group of data here. It could be whatever. How many points Nakai scored in basketball games this year? Let's call it that. He scored 14 points in his first game, 30 points in the second game, 16 points and 20 points. Yeah, he had a good season. 18 points, 16, 20, 18, 22, 13. And then in the last game, he was on a minutes restriction because we had already qualified for the playoffs, so he only scored 8 there because he didn't play that much. When you're going to do a box and whisker plot, you need to find your medians and your quartiles. In order to do that, you have to put the numbers in order. How many numbers do I have here? Are there 11? 1, 2, 3, 4, 5. Yep, 11. Good. And then what they've done for you is they put them in order. Is 11 an odd number or an even number? Odd. So that means as far as the median goes, you should have exactly one number in the middle. What is that one number in the middle? Huh? Okay. Where it says Q2, anytime you see Q2, that's the same thing as saying the median. Feel free to write in median. Okay. The maximum is your biggest number. The minimum is the lowest number. Because 11 is an odd number, if you're going to calculate quartiles, I told you would have to take the middle number out. When it's odd, you got to take the middle number out. How many numbers are there left on each side? If I take the middle number out, how many are there on each side? 5. Is 5 an odd number or an even number? Odd. And because that happens to also be odd, there should already be one number in the middle. We don't have to take the average of anything. So the number in the middle on the front end is the 14. That becomes quartile 1, or what we call the lower quartile. And on the high end, it's 20. But before you can do a box and whisker plot, you need to see if any of these numbers are considered outliers. If I'm trying to figure out what type of basketball player Nakai is, I got to figure out, hey, you know, on that high end and the low end, when he scored 30, was that just because maybe he was playing against such a bad team that was just way out of control? Like, I should never really expect him to score 30 again. Or on the low end, you know, maybe he was hurt that day, or maybe, you know, if I want to know, like, try to figure out the likelihood that one of these extremes would happen again, if I want to know how, you know, do they really belong with the rest of them, I would want to calculate to see if they're an outlier. Are they considered to be outliers? Like, very unlikely to happen again. So the way you do that is you would first calculate your interquartile range. How did I tell you to calculate interquartile range? Subtract what? And anytime you see range, you subtract. What do you subtract for interquartile range? The upper and the lower quartiles, which is 20 minus 14, where 20 minus 14 is 6. But then you have to get that interquartile range and multiply it by 1.5. What is 1.5 times 6? What is 1.5 times 6? Ready, set, calculate. It is 9. So then what you're supposed to do is get your low quartile. What was my low quartile? 14. And then subtract 9. And then go to the high end, which was 20, and add 9. So what this tells us is that any numbers that are either less than 5 or greater than 29 should be considered outliers. They should really not be considered part of the rest of the bunch, and it is extremely unlikely that it would ever happen again. Can any of these numbers here be considered outliers? No. Are any of these numbers... I can't draw on this thing again. I'm just not drawing anywhere. This one lets me draw, this one doesn't. Now it's gone completely. Hold on. Let me close this out and open it up again. Martha, it's all your fault. Okay, so let's see if this will work now. What this is telling, remember, the way that I got these 9s are by getting by getting 6 and multiplying it times 1.5. I took it away from the low end, I added it to the high end. Do any of these numbers up here fall outside of that range of outliers? Are any of these numbers either less than 5 or greater than 29?
Yes.
Which ones?
30.
Just 30. So, all of those seem to be in the correct group, but the one that seems kind of out of place is the 30. If indeed these were like Nakai's scoring games this year on the basketball team, it would seem unlikely that he would score 30 again. Okay. Now here comes the box and whisker plot. Now that we have all that information, here's what a box and whisker plot looks like. Okay, you have a number line. The box on the number line, the outline of the box goes from quartile 1 to quartile 2. And then just connect make it look like a rectangle. Okay, this first line here is Q1. This is Q3. The line in the middle is going to be wherever the median was. Where did we say the median was going to be? 18. Okay, this is Q2. Then wherever your lowest and highest point are, as long as they're not considered outliers. What was our highest point that was not considered to be an outlier? No, 30 was the max, but it ended up being an outlier. So what was the next highest one? 22. You see a point there, and then that's the whisker in box and whisker. The box is the rectangle. That little line is like the whisker, like a cat whisker. Meow. What was the minimum? 8. Was 8 considered to be an outlier? No. So that's why you can put a point at 8. But we need to be able to describe the entire data set. Even though Nakai might not be likely to score 30 points again, the fact is that he did score 30 points. So the way you would do that, you just don't connect it with a whisker, but you would still put a point out at 30. Any questions there? Because now the rest of the packet is going to be examples. So let's see how many we can do, and then we'll move on. All right, mean, median, mode. For mean, you do not need to put the numbers in order. You just have to add them. So let's see if I can do this mentally. For this group A is 16, 18, 21, 26, 32, 36, 42, 53. I know some of you guys are ahead of me. Did those add up to 53? They did? Okay. And then divided by how many are there in total? By 9. Okay, so it is possible to get a decimal. It looks like it's going to be a pretty nasty decimal. It's going to be like 5.1. 5.6. 5 and 8, 9. So then what'd you get then? 5 point. And it doesn't tell you what around. So let's just say it's going to be around 5.9. For the median, you would have to put them in order. So let's see, 2, 3, 4, 5, 6, 7, 9, and 11. Always check, because even me, I sometimes mess up and I forget to put some of these in. It looks like I do have 9. Is 9 an odd number or an even number? So because it's an odd, I should have 1 directly in the middle. It's whatever the 5th one is here. The 5th one is 6. That also is my median. Notice how, in this case, the mean and median are pretty much the same. The mode, just for fun, you don't have to have a mode, but does this set have a mode? Remember, mode is the most frequently occurring. Yeah, it is 6. 6 is the only one that appears twice. Let's do the next one. Oh, geez. How to do this, man? 74, 80, 101, 120, 147, 180, 214, 234, 255. You're getting 222 for the second one? I got 255. And you want to break the tie? I did it in my head. For B, what do all of those add up to? 256? Martha, I was close to Martha. I win. 52, 256? Yeah. Okay, I'm going to trust you. Don't make me look foolish on video. So 256 divided by how many are there? 1, 2, 3, 4, 10? Are there 10 of them there? Okay, so that's going to be 25, 26. That's the mean there. For median, you got to put them in order. So 19, 20, 21, 21. It's a good idea maybe to scratch these off as you go for median, so that you know you've already used it. 23, 27, 27 again, 31, 33, and 34. When you have an even amount, what do you got to do to find median? What do you have to do to find median when there's an even amount?
The middle.
Get the 2 in the middle, add them, and divide by 2. You're basically taking the average of the middle. So here the 2 in the middle are 23 and 27. So 23 plus 27 divided by 2 is 25. The median here is 25. Does this set have a mode? Yes, it actually has multiple modes. It has more than one mode. What are the modes here? Yeah, 21 and 27. Those are both modes. The only way it wouldn't have a mode is if nothing appears more than once. Look, this last question today I already answered for you. Which center measure is most appropriate and why? I haven't even done the problem, but I already know what the answer is going to be there. Which center measure is usually the most appropriate? Huh? The median. Why the median? It's less susceptible. Let's see if I think of a better word. Less susceptible. Let's call that right. To extremes. Here's a group of data. See, a person is trying to find. This will be the last one today. New employees to work for his company. She wants to show applicants a statistic about how much they make. Which measure of center would be best to describe the salaries if she knows that 10 of her employees make? Oh, well, okay, well, this is a skewed question because it looks like it's coming from the viewpoint of the person who's doing the interviewing. If you own a company, do you want to make it seem like your company gives out bigger salaries or that you pay less? Yeah. So you probably have to find it first and then see which one ends up being higher, and then that's the one you want to go with. Like typically, like if I'm the one who's being interviewed, I'm gonna want to use median because median, if 9 people make $20,000, but then one person makes $5 million, that mean is gonna be huge. But in reality, a bunch of people are making peanuts. You understand what I'm saying? So like median would be the better one, to be the more accurate one. But if you're the boss and you're trying to make it seem like you pay more, we gotta see which one will be better. Did anybody add these up already?
I did.
What'd you get for what did they add up to?
I did.
You didn't add them up? What, you went like on the calculator on an app does it for you? You can write it down. 21,
I think it's
112. How much? 710 and then 000 divided by 10 because there's 10 of them. So that would be 71,000 is the mean. The median, you have to put them in order. I guess they kind of are in order since there's 10 of them. It's these two in the middle. Are those the two in the middle, right?
Yeah.
So, I know that they're not in order, but but the 70. I didn't catch. So it'll be these two are the ones in the middle. I know it's not in the middle, but I'm trying to save time because the bell's about to ring. 81 and 88 are the ones in the middle, you think? Yeah, because this is third, fourth. So this is fifth. Okay, so these two are in the middle. Okay, yeah, all right. And yeah, because then the ones and 90s are bigger. And then that averages out to 85.5 or 84.5? 84.5. So the median ends up being 84.5. So if I'm the boss and I'm trying to make my business seem better, would you use the median or the mean here? If you're trying to make the, yeah, yeah, it would be the median. But if you're the person being interviewed, well, which one would be more important to you probably? Actually, you know what? Median would still be important because median is the most accurate one. So median works out well. And which one was the mode? Is there a mode here? 91. Okay, so the 91,000 is the mode. Tomorrow we'll start with the next page.